Hi, welcome to part 2 of the lecture on chapter 11, building a small network. So this week we're going to talk about basic network performance, some basic shell commands and utilities that you can help baseline your network, output of the ping command, output of traceroute. So just some basic command structure to help you manage that performance. And then probably what a lot of people find the hardest part to do is network troubleshooting. Talk about different methodologies, some cable issues, issues with devices. So we'll cover those. So let's look at basic network performance. Now, we have used the ping command pretty much almost the whole semester. It's a very effective way to test connectivity. It uses the ICMP protocol, and it verifies layer 3 connectivity. So that way, and of course, hopefully you understand what layer 3 connectivity means. So it has different indicators in it. You've seen the exclamation point, meaning this is what you wanted to see. You saw the dots were maybe timed out. And sometimes you may have seen a U where it actually meant it was unreachable. It just never could get there. Now, there are ways of extending the ping to make the ping command do a little bit more than you want. Now, to get in this mode, you just type in ping, but don't, you just want to make sure without giving an IP address, you just hit return, and it would get you into the extended program. And now you've got options in setting, you definitely have to specify the IP address because you still need to know what the target address is. But now I can change the number of times I repeat, the size of the packet I'm sending, what causes what acceptable timeout procedure. So you get a lot more options in setting up your ping command, which can be very beneficial. It also can be one, if you set values too high, you can bring your network to your knees. So be careful. Now, one of the things that you like to do on a network is I need to understand how the network is performing before I make any changes to it. So I need to understand what is the network as today's standard, which is basically a baseline. So I'm going to run some tests and say, okay, what is my connectivity based on the way it is today? And record that. I may do a trace on how often does it take, how do I get to a particular server, so that I know which servers it go through, how long it takes, so that before I make a change, I can understand where the network's running, so that if I do something, I'm hoping I'm improving the network and not detracting from it. There's definitely a whole lot of corporate systems that have a whole lot better, more complicated baselining, but it's outside the scope of this class. Now, one thing is I want to do, if I do a trace, or if you're using Windows, trace RT, is basically what is it doing? It's saying I'm testing which routers did I hit along the whole process. Now, if a trace times out, that means that the router couldn't respond. So it could have been the network's down, connectivity of the network. It could have meant that the router itself was down. So there's a lot of different options when you get a trace, but it's just saying I'm going to follow the path from computer A, and which routers am I hitting before I get to like the computer B that I'm tracking. Now, as with ping, there's an extended trace, and basically allows you to adjust the parameters of the command. it can be helpful in troubleshooting loops in your network, or the exact number of who the next hop router is going to be. Basically similar to the ping, you just type in traceroute and hit enter. Don't give it an IP address, and then proceed to provide whatever additional information you want. Now, I'm going to give you, I think one of the packet tracer labs I gave you was the traceroute, because this week you will have 3 packet tracer labs, so you'll at least test some connectivity, both probably with ping and with traceroute. Except this one, you won't do this one because it wasn't packet tracer. I should remove these from the lecture next time. Now, you've used show commands. Now, show commands, we're just going to revisit these a little bit, but they're basically used to figure out what configuration you currently have, and is definitely very useful in troubleshooting purposes. Some common show commands are the running configuration, interfaces, the ARP command, the routing IP route, show protocols, and show versions. And all of these we've used this semester. Now, the video online is very good at using the show version. And basically, a lot of the cases what I'm doing here is I want to make sure that what software version is running to say, hey, I've been told there's a new version that's run out for this router. Do I want to upgrade it? So it gives you information, but it also tells me what? It tells me the releases. It tells me a whole lot of other things, how much memory is being used. And so there are tons of things. You will have a lab on using show commands, so that one shouldn't be too difficult. Now, I shouldn't say all, I think in this semester you've looked at the ipconfig command to figure out what your current IP address was. To get the MAC addresses, you'd use the ipconfig/all. But you also could use the ipconfig/display DNS command to show what DNS entries are on the current Windows computer you're on. So it gives you a lot of different options, but these are some of the big ones that you use. We've looked at the address resolution protocol. Here you see the command being used again on a Windows computer. So it gives you the IPv4 address. It gives you the MAC address, and whether it's static or dynamic. Show CDP neighbors command. There are times where CDP is Cisco Discovery Protocol, and it runs at the data link layer, but allows you to check to learn about neighboring devices, even if you don't have layer 3 connectivity. Even though I don't have an IP address associated with it, I can go out and see what devices are connected to me, even though I don't know about them. Because CDPs run automatically, it discovers it, and there's a lot of information you can determine. What interface, what platform is it. So it can give you a lot of information as far as what you're connected to, even though you may not know that. Now, hopefully you've used the show IP interface brief command, which basically tells me what all my interfaces are, if I've got an IP address associated to it, if it's up or down. So it tells me, is it working, and which protocol is it working through. So you're going to get a chance to run a packet tracer with this, but not this. You won't be doing this lab. Now, there's a command called debug. Debug allows me to record all the messages. Now, remember when you make a change to anything in the system, you sign an IP address, you hit enter, and all of a sudden you see a message appear, display, status display on your computer. Well, show debug says, hey, I want to debug certain commands. It allows me to save messages in real time. But be careful that I can ask to, if I just turn debug totally on and tell me everything that's going on in the system, it can definitely just inundate you with messages to your screen that you don't want to see. Now, to turn it off, the quickest way is undebug all. And usually before I start a debug, I'll make sure that I'll have that message already typed in, ready to go, just so I can turn it off when I need to. Now, there's a terminal monitor command. And basically, you can say, do I want to display log messages or not? So I can turn it on or turn it off. And it just allows me to see what, right now we've got terminal monitoring on for everything that we're displaying. So that way you see how the log message is coming. So just know that that command exists. So now how do I use those commands to troubleshoot a network? Now, there are basic troubleshooting techniques. Here's one that's a 6-step troubleshooting. Basically, what I have to identify the problem. I got to kind of come up with a theory, what could be causing the problem. Of course, I want to test that theory. And then it says, once I tested my theory, maybe that theory's proven true. Now the question is, what am I going to do to fix the problem? So because I had a theory doesn't necessarily mean I had a solution. Then once I've determined that solution, then I will verify, I'll implement it, verify, document my findings, and go through. So, so that's the theory of troubleshooting at a high level. But as with any project manager with any tech, network problem, I got to say, okay, am I the one who's going to respond to this, or do I escalate it? Do I have to find someone else to do it? Whether it's a manager's approval or maybe a more senior network engineer to do it. So it just depends on who's responsible for it, and is it something I found and I can fix. Now, we can, first thing you want to do is I want to verify and monitor the system. What I can do, I can verify that with ping, traceroute, show interface, brief. Those 3 commands basically will tell me who's connected to me and what their statuses are in operation. Now, sometimes in older networks, they don't have duplex. Auto negotiation is a default, which means I don't care. But in the older networks, you need to make sure that your duplex message, otherwise you don't communicate. So you may see a duplex issue in one of the labs. So pay attention to that. It's just a way of checking. You both switch and router or both devices have to be either full or half duplex. Of course, you remember that half duplex is one-way communication. Full duplexes, both parties can talk and receive at the same time. But just keep in mind, both must be set to full or half. And auto negotiation was designed to help. So, but just know, if auto negotiation is off, you got to make sure they match. Now, how do I see this? Well, they're difficult to troubleshoot. Ping won't detect it. CDP can detect it. And here you see an example of, you're seeing that mismatch. So just keep in mind. Now, other issues, IP addressing issues, show IP interface on a particular interface. But I'll start with the show IP interface brief, and then if I need more specifics, more data about that interface, then I'll go to the show IP interface command without the brief one. Now, definitely IP addresses on end devices. You're going to use your IP config. You're going to make sure that I know what the IP address is for my device. If you get an IP address that starts 169.254, that means you do not have an IP address on the local network. So basically, it won't work to anybody. So you need to make, if you see that, then you know that your IP address, either from your DHCP or you manually forgot to do it, you're going to see that kind of message. And then you're going to say, okay, why didn't the DHCP, catch it? But in most end devices, it's done with DHCP. If that's up and running, if you can get access to the DHCP server, you'll have an IP address, and your IP config command will tell you how to do this. Now, there are times where you have default gateway issues. Now, default gateway is what? It's the end device, the closest networking device that can forward traffic to other networks. And if you don't have a valid one, you won't communicate outside of the current network. One, you got to make sure that your current host is part of that default gateway network. You can manually set it or get it from the DHCP. Usually it's set up through the DHCP. IP config will show you that. The same thing so will show IP route, and it'll say, hey, my gateway of last resort tells me which is the interface. It tells me who's going to send me out. Who is it? In this case, to get to any outside network, it's going to be that 10.1002 is the IP address of the router that gets me beyond my default gateway. Now, DNS, okay, of course we know what is it matches up IP addresses with your URL. So it allows us not have to remember a bunch of numbers. But if that system's down, you're going to see that. You may see when you do an IP config all that DNS server is down. But usually it's set up through DHCP, and you never have to worry about it. Now, you're going to have a packet tracer lab on how to verify some connectivity, and it'll just give you some ways of practicing troubleshooting techniques that you've learned in this chapter. Now, I don't know if I gave you the connectivity lab, but it'll tell you in Moodle which assignments I gave you. So in this chapter, we've learned a little bit about, not going to do the integration, troubleshooting channels. So you've pretty much learned a little bit about some of the features and functions of Cisco IOS, how to configure a small network, IP configuration schemes, addressing configuration, end-to-end testing connectivity that you needed to do. So hopefully this gives you a nice way of wrapping up this course. This will be the last chapter exam, or the last chapter we're going to cover. So good luck, and if you have any questions, give me a call.